10 minutes, 15 minutes maybe, to go through the notes on So today I asked this question. It says, how did our ancient ancestors calculate measurements for objects that they could not measure directly? For example, heights of large structures or natural objects, distances across water, etc. They did not have all the sophisticated technology that we have today, so they had to be creative. Right? So I pose this question, something that you guys, I'm sure, have happened to you all the time. Walking home from school, come to a tree, you look at that tree, and you just wonder to yourself, how tall is this tree, right? Very identifiable problem, right? You look at it and you're just like, I don't feel fulfilled unless I know how tall that oak tree is right there. Happens to all of us, all right? But if you wanted to find the height of that tree, I wouldn't suggest you shimmying to the top of it with your friend and have some measuring device to drop it down, all right? There are other ways to do that, and that's what we're going to talk about. This highlights an example of something that we could use called indirect measurement. And in this case, we could utilize shadows or measurements on the ground, the safer version of this, that we could actually calculate a little bit more directly. Okay, now it mentioned up above how we don't have all the sophisticated technology, or they didn't. We do now. We have crazy amounts of technology that we could use to estimate this, okay? But they didn't always have this, okay? Or maybe you don't have it at your fingertips, and we have to be creative in how we solve certain things. So what we're presenting here in a more sophisticated example, okay, to the right, you have your tree, you have this person or this distance right here, this height A, okay? And we're going to utilize shadows for this. So what this would mean is, if you look at the tree, which would be referenced as the height of H, that tree on a sunny day, which we don't get too many of those anymore here, but that would cast a shadow of a certain length, and that shadow length here would be represented by the value C. Well, if you went and stood nearby that tree and looked at the shadow that you create, B, your height would be A, you could use that information to estimate how tall the tree is without actually climbing the tree, right? Because I can measure the shadow length of a tree. You already know how tall you are. You know how long your shadow is. That would avoid that dangerous task of trying to climb that tree, okay? And now all of your questions are answered, right? Now you can just be on your merry way home, and it's going to be a good day because now you know how tall that tree is that's been haunting you all this time, right? We're going to use the concept of proportional reasoning here. So if I set this up just in this box, there's a lot of space here to do very little work. If I were to write a proportion to calculate the value of H, I guess for any value, because I'm not putting numbers in there. I'm not putting specific numbers. Yeah, we will. Can you give me a proportion that I could set up that references this concept of similarity? And if you haven't seen it yet, or if you can't see it, notice how I've got a triangle there, and I've got a triangle here. We talked about inscribed triangles yesterday, how one can fit inside the other. Well, that's what I have. The yellow triangle would be similar to the green triangle. Okay? So let's go with a proportion. Can anyone give me a proportion, or get you started on it? None of you got like H over C, okay? So the height of the tree compared to the shadow of the tree, relative to the shadow of the tree, is equal to the height of the person, or the maybe it's a smaller tree, who knows, okay, over the shadow length of that. Okay, that would be a proportion that we could use. Somebody give me a different one, just to highlight our ability to create different proportions here. Instead of going H to C, A to B. Cameron? Cameron?
C over B equals H to A.
So she went shadow length of the tree, shadow length of the person or the smaller tree, height of the tree, height of the person. Good. Okay. So all we're doing is pulling all of this information in, the concept of similarity, the concept of proportions, the concept of scales. We'll see that in a minute too. So that we can apply it to not measuring something with actual tape measures or rulers or other devices like that. All right, this is that concept of indirect measurement. Okay, so here's our definition. The only definition we have, in the last definition of this unit, the process of using similar triangles to measure objects that are too difficult to measure directly. So now we're going to do an example very similar to the one above, except now with some actual data behind it. Not talking about a tree, we're talking about a flagpole. So it says a 6-foot man casts a 17-foot shadow, and nearby a flagpole casts a shadow that's 51 feet long. We want to find the height of the flagpole using a proportion. Or you don't have to use a proportion. We could use scale factors if we want. Okay, because you're going to see this whole similarity concept. So the one box on the left says draw it. I always recommend, if you can, if it doesn't provide the drawing, give yourself a visual. Get something to work with here. So I'm going to draw a flagpole. The shadow length on that flagpole is 51 feet. I don't know how tall the flagpole is. That's obviously what I'm looking to find, so maybe I'll call that H for height. But if you notice here, the sun shining creates this shadow, so you would create this triangular effect from that. All right, and then nearby, you have a person. Here's my person. You don't have to put as much detail into your drawing as I did. You can just draw a person, okay? So you have this 6-foot tall person, so this is 6 feet, casting a shadow. We said that is 17 feet long. And again, you're going to create that triangular effect. Lesh. And when you draw it out like that, it makes it a little bit more manageable, or a lot more manageable, I think, because now you can see the similarity concept. So give me a proportion that we could use to find H. Go ahead, Max. So 51 feet, shadow length of the flagpole to shadow length of the person. And then you said H over 6. Yep. Good. All All right, go ahead and solve. Find out what h is going to be. What do you have, Ava? 18 feet? Looks good to me. Okay? I don't know if any of you caught this. I asked you to use a proportion, but you didn't have to. Did any of you find a scale factor, see a scale factor relating the person shadow with the flagpole shadow? What about 51 and 17? How are they related? Jack? Exactly. Now, numerically, how are they rated? Or how are they related? Is 17 a factor of 51? I know we think 17, oh, it's prime, so, but it is. Like some of you said, yeah. How many times does 17 go into 51? Emily? 3. So you could say, well, the shadow length is 3 times the length. So then the height must be 3 times the height of the person, which in fact it is. It ends up being 18, right? So that could have been another approach that we were using. All right, let's turn it over. 2 more examples, and then we're done with this section here. This one's talking about finding the distance across the lake. So you got a lake. You want to know how far it is from the, the longest 2 endpoints. Well, one way it looks like they're doing here is creating this similar triangle effect, but you're measuring it in a much more safe environment because you're measuring it on the lands. Okay? So they've created this triangle, this ABC triangle right here, with a couple of dimensions. So they have devices to measure these distances here. It's just not conducive to go across the water like that. And we're going to compare that to the larger triangle that we see here, this outside triangle. And we can use that information to find this distance across the lake. So I'm going to stop there because we've done these inscribed triangles before. Go ahead and try that. Find out what D. This means D in meters. That's like the distance in meters. That's what that means. Okay? So go ahead and work that out. Make sure your answer makes sense, too. I've seen some answers that aren't realistic. far is it across the lake? What we find out? Rule, what do you have? Well, it'd be, these are meters, not miles. 25 meters. Did anyone else get 25 meters on this? Okay, let's talk about how you got that, Arul. AC, yep. Which is what, by the way? Nope. Yeah, numerically, it's 350, right? So it's 350 meters from A to C, okay? Over its corresponding length on the ground, yep. Oh, okay, I'll put D, but yeah. D to 20, okay? Cross multiply and solve, yeah. And you get D is equal to 20, or 25. Okay? Now, a common mistake, and I don't know if any of you made it here, common mistake lies in with this 70, and I see this people do this all the time, and I just want to point it out just because some of us might have made it, or we might be prone to making it in the future. Does anyone know what mistake I'm talking about? Ben? B to C, okay. Right. So let's say we did it like this. Let's say I did 280 to 70, and then I did 20 to D. Let's say we make this mistake. We said, oh, well, I'm going to set up a proportion here. 280 to 70 is equivalent to the same ratio as 20 to this distance across the lake. Now, when you solve this, because I see this a lot on this problem, D is what when you solve this one? Cameron? 5 meters. Okay. So I said before, make sure your answer is reasonable. I don't know how familiar you guys are with the definition of a lake. Okay? Most lakes are not 5 meters across at their widest point. Okay? That's not called a lake, that's called a puddle. Okay? That's a mud puddle, right? That wouldn't be a reasonable answer in this situation. So when you guys are checking your answer for reasonability, right? You're like, oh, is this true? This would probably set off an alarm, like, oh, wait, that doesn't seem right, because it's not. 25 meters, yeah, you're looking at, still more of a pond, I would say, at this point, but nonetheless, that would still be more reasonable than the other. Okay, now look down at the one below. This is our last one. What do we do in a situation where you have an image that's not even labeled on mine, but it's labeled on yours? You have two triangles that are attached by one vertex and some corresponding lengths that are mentioned there. So what I'd like you to do is use that information above where it says triangle ABC is similar to triangle EDC. Use that to match up your vertices and find that missing length, which in this case was labeled D. I will label while you work. I was curious when I took a walk. I'm just curious how many of us redrew these shapes just to kind of get a better understanding of them. And some of us did, and I'm not making you. You don't have to. That's a tool that you could use to help you, especially for us that are more visual and you want to see it. It's hard to connect otherwise. Perhaps you redraw these as two separate triangles and then label them accordingly, like C, E, D. D there. This would be your C here, and then your A, and then your B right there, and then you can label your sides accordingly. I'm not going to label all of that, but that's how you could do it. And then you just have basic similar triangles. Others, I think, kind of maybe thought, well, if I rotate this one this way, it'll kind of lay down on top of it, and I can see it that way. Whatever works for you. You can see it, and you don't have to. If you used a proportion, can you tell us what your proportion was, please? What do you have? Ava? So 141 corresponds to 312. Those are corresponding parts, and D and 416 are corresponding parts. And if you rotated them, you would see that. When you solved that, what did you get, Ava? 188 meters. Okay. Did anyone find a scale factor on this one? Just curious. What was it, Aiden? So from the small to the big, like 141 divided by 312. 500.45. Did anybody find a scale factor but do it the other way, from big to small? What was that one, Jack? Okay. So then what did you do with that 2.21 number? Yeah. Was it 2.212? Yeah, whatever. Okay. So you can see how scale factor could be applied here too. And you just divide them out, and then you're going to be left with 180. Okay? So that's indirect measurement. You can see how similarity connects with that. All right. So what I want